Waouh, ça doit être la première fois que je ne vois pas de mouvement suite à cette déclaration. Qui sait ici ce qu'est le MS... Alors attendez, moi-même j'ai un trou. Le MSRC. Juste une personne? Bon bah pourtant là vous allez apprendre quelque chose d'intéressant. Vous allez apprendre que le MSRC c'est le classement des plus gros chercheurs de vulnérabilité au niveau de Microsoft, donc publié par Microsoft eux-mêmes, et particulièrement donc c'est connu pour son top 100. Et bien notre interlocuteur justement sur ce sujet, bon, il spoil un peu, est membre de ce classement. Je ne sais plus à quelle position. Je crois que c'est la 37e position. Et justement, comment il y est arrivé avec tout ce qui est fuzzing. Je le laisse parler.
Hey, thanks. So, bonjour SigSegv1. I have no idea what he told about me, but it sounded really cool. So, thanks for that. So, as you might have already understood that this talk is going to be in English, so please bear with me for next 30-40 minutes. So, first of all, I'd like to thank you everyone for coming over to listen to the presentation today, and thank you SigSegv1 for having me. This is indeed my great pleasure to be here with you. So, from the title, you might have already understood that this talk is going to be about fuzzing. Just to make one thing very clear at the beginning, that I'm not going to be talking about any rocket science about fuzzing. What I'll be sharing today is some of my experience and some of the techniques and approach that I have found quite useful during my bug hunting journey. So I have been exploring vulnerabilities in different Microsoft and other products for a while now, and this presentation titled The Fuzzy Shortcut to MSRC Top 100 kind of summarizes some of my findings and some of the work that I have done in recent past. So this is about me. My name is Debasish Mandal. I'm coming here all the way from India, and currently I'm working as a security researcher at McAfee Endpoint Exploit Prevention team. And I have been working in this information security industry for past 6+ years. And initially I was a pen tester, and last 3-4 years, my primary focus has been shifted to vulnerability research and system security. So this is a very brief agenda of our talk today. I'll be starting with some of the background about fuzzing and test case generation, and after that I'll be touching some of the motivation behind this research, why I started this work, and what was the primary major motivation behind this research. And after that I'll be sharing some of the details of our fuzzer and the fuzzer test case generation that we have developed during this process. And we'll be also touching some of the targets that we have targeted during this research, and we'll be sharing some of the details of the toolkit that we have developed, and post-talk will be open sourcing some of this. So we'll be talking about some of the details of that. So fuzzing is an automated method for inserting mutated and unexpected input to a system just to test how well the system responds to it. So by inserting unexpected input to the system, what we try to do, we try to see So by inserting an unexpected input to a system, what we try to do, we try to see how well the system responds to it. And usually for fuzzing, a large number of test cases is required. So for that, some kind of automation is required, and it is usually done using a dedicated automation system, which is called the test case generator. So the test case generator and the target application, we have to make very sure that they are on the same page. So we have to make sure that the interaction between test case generator and the target application are proper, and so that to be able to make the communication seamless and effective, we have to make sure that the test case generator have very good understanding of the input format the target application understands. So now, since we are talking about the importance of interaction between fuzzer and the test case generator, the more we are good at training our test case generator, the input file format that the target application understands, the more effective the fuzzing would be. Now the question is, how do you do that? So there are various effective techniques to train or teach our test case generator different file format or input format. So some of these techniques are very closely related to the learning capabilities of human being. So one of the coolest learning capability a human brain has is learning new languages. So we are going to see in this presentation whether if we can apply the similar technique to generate effective test cases for our fuzzing. So when it comes to learning and enriching a new language, there are several effective techniques. So one of the technique is the sentence mining. So sentence mining actually encourages a language learner to memorize long list of sentences instead of memorizing vocabulary and grammars. So as the name suggests, instead of memorizing long list of vocabulary, in sentence mining technique, learner has to memorize sample sentences and studying them over and over again. So sentence mining is all about learning grammar and vocabulary in the context of real life sentences, recognizing pattern in them, and craft new sentences every time by swapping existing grammar and vocabulary with a new one. So human brain does that pretty seamlessly. So here's an example. So let's have a close look how human brain learns a new language. So babies don't learn new language by studying textbook or grammars. So they actually learn any new language by hearing same thing over and over here again. So here's an example of a toddler. So one day the toddler hears a sentence something like this: I put a little food on the table. And the next day it hears I squeezed a little lemon on the avocado toast. So next day the baby automatically comes up with something like this. So what just happened here? So that was baby's first sentence. So if you break this into parts, it may sound very simple thing, but we will get to see 4 basic steps here. So the first step is memorizing sample sentences. And after that, the second step is recognizing pattern and turning the sample sentences into sentence templates. And after that, the third step is memorizing vocabulary. And the third and final step is to crafting new sentences based on collected sample sentence and what grammar and vocabulary you have collected in those previous steps. So browser fuzzing is a very fascinating topic. I wanted to see if we can implement the sentence mining like technique to write down effective test cases for our browser fuzzer. So I was looking back some of the research that has been done on browser fuzzing. I have found quite a lot of research, especially this research grabbed my attention. So the title of this presentation was Power in Pairs, and it says how one fuzzing template revealed over 100 UAF vulnerabilities. So this was presented in Black Hat Europe, and so what they have done is they have spent quite a lot of time analyzing different browser exploit samples, and they have come with a single HTML page template, which looks something like this. As you can see, there are some JavaScript code and some blank functions. So what they have done is they are actually injecting some JavaScript code to mutate document object model into the same template and opening the test case into the browser, into Internet Explorer and other browsers. So it proven to be very successful for them, and they found quite a lot of bugs using this technique. So we thought of applying similar fuzzing strategy, but bit differently. So when it comes to browser fuzzing, there are primarily 3 or 4 targets that we have seen that is very popular among vulnerability researchers. The first one is the HTML and CSS render engine, and the second one is JavaScript interpreter. So fuzzing on them usually performed by manipulating document object model using JavaScript. So there are plenty of JavaScript-based DOM fuzzing algorithm that has been already open sourced, and if you want to find browser bug, so using the same technique over and over again is not making any sense. So, and also coming up with a completely new and effective DOM mutation fuzzing logic which may give us a bug, requires a lot of effort, because it may require source code review, or there are many other tiresome process. So I did not want to do that. So what I thought of doing, I thought of combining these two techniques along with some open source DOM mutation logic, and these three things together, and I named it as template mining. So today's presentation, I'm going to be talking about primarily two targets. Among web browser, we'll be primarily covering Microsoft Edge web browser, and also we'll be talking about targeting, how can we target Microsoft Outlook email render engine. So how can we generate effective test cases for our browser fuzzing in the same way we have seen sentence mining work? So in sentence mining, the first step is memorizing sample sentences. So in template mining, what we can do here is we can collect sample web pages from different sources. And the next step is sentence mining is pattern recognition in those sample sentences and turning those sample sentences into sentence template. So here also the collected raw web pages will be we have to pass it through some pattern recognition engine, so that we can do identify scope of different codes present in those web pages, and we can also grab grammars from them. And the third step is memorizing grammar and vocabulary. So in the second step, when we parse those raw web pages, we also try to collect different grammar from those web pages. So last and final step is swapping existing vocabulary in sentence template with a new one from the memorized list. And in our fuzzing case, what we are going to do here, the sentence, we are going to inject some fuzzing code into those mined web pages in the fourth step. So this is an overview of the test case generator that we have developed. So first step is the template miner. So the template miner actually tries to grab different web pages from the internet, and after that, these web pages will be passed to a pattern recognition engine. So the pattern recognition engine will have two parts. The first part is the grammar identification. So this grammar identification engine will actually try to grab the CSS and HTML and JavaScript grammar from those raw web pages, and it will actually pass it through the grammar processor. And finally, it will actually save those grammars into a grammar database. And pattern recognition engine also has another part, which is scope identification. So the scope identification is a process where we finally, after parsing those web pages, what we do, we turn those web page template into a fuzzer-friendly template DB. And finally, we combine those grammar database and fuzzer-friendly template database, and we generate a final HTML, CSS, and JavaScript test case for the browser. So now we are going to talk about some of the details of each step, what you have seen in the last diagram. So first step is the template gathering. So as the name suggests, in this step, complex web pages with rich JavaScript and CSS are collected from different sources. So complexity of the fuzzing template usually will if we increase the complexity of the fuzzing template, it will increase the code coverage. So that was our initial assumption. So we were actually gathering different web pages from following sources. So the CodePen, JSFiddle, CSS Deck, LiveWeb, and GitHub.com. So this was an automated way to grab pages from different sources. So sources were, we have chosen these sources because it was we wanted some standalone web pages, not like, because JavaScript code will have a lot of cross references, and initially we wanted to avoid those. So we are actually grabbing pages from these sources. So now, once the web pages are collected and mined, so we had to pass this through a pattern recognition engine. So pattern recognition engine, this process has actually, the main goal of this process is to get two things out of these raw templates. The first thing is CSS JavaScript grammar, which are actually our vocabulary, and the fuzzer-friendly template. So the pattern recognition has, if we break down the pattern recognition process, it will have following things. So first of all, we try to look for HTML style and script blocks in those gathered web pages. And after that, we try to identify JavaScript, the scope of JavaScript codes, which portion of the JavaScript codes are local and which are global. And after that, we also try to identify different JavaScript statements. And we also try to in the CSS, in the style block, we also try to recognize CSS selector block so that we can inject CSS code in those web pages. So here is an example of scope recognition under CSS of CSS and JS. So the example that you see in the left side is a sample CSS code. As you can see here, there are two places we need to identify here, which is where the CSS block starts and where the CSS blocks end. So in those places, actually, we can inject our fuzzing code. So that is what our primary goal here. And the right side, what you see here is a sample JavaScript code. So our pattern recognition engine will try to identify the local scope of the JavaScript code and also the global scope, so that we can inject code into those places. So JavaScript statement identification is where our pattern recognition engine will try to identify different if and else statement inside JavaScript code, so that we can inject our fuzzing code into those places. So this is an example of the final output of the pattern recognition engine gives us. So as you can see here, the left side, what you see is a raw template, and after it passes through the pattern recognition engine, it inserts some fuzzing token into the CSS block and the script block. So our fuzzer actually later on is going to inject code inside, replacing it will replace those fuzzing tokens, and it will inject code into those places. So now we already have a fuzzer-friendly template. So now we will have to collect grammar. So from where we can collect grammars? So the primary source of grammar is the mined web pages, what we have collected previously. And also we can collect JavaScript and CSS grammar from existing open source fuzzers. And the last one is the W3 school. So W3 school has a very good source of grammars. So as you can see here, here is an example. What you can see here, it shows the CSS attribute box shadow, and it will also give you a lot of information what could be the possible values of that. And it has different OR condition. So using those statement from the W3 school, we can easily feed all these things into our fuzzer, and the fuzzer we can write some logic to understand what will be the appropriate value for those attributes. So once we collect those CSS grammar from raw web pages, so some CSS grammar processing is also required. So once the raw grammars are collected and stored in a temporary database, it also passes through one of the processing engine. So the primary job of this processing is to identify CSS grammar attribute and its data type identification. So here's an example of that. As you can see here, for example, if we get something like this, top minus top, the CSS attribute is top, and the value is minus 300 px. So once it passes through the CSS grammar processing engine, so what it tries to identify, that attribute name will be top, and the value of this, it will be minus 300 px. So after the pattern recognition process will give us output something like this. So attribute value will be top, and it will replace the sign with a token sign, so that our fuzzer can replace those later on for fuzzing. And it will also replace the integer part with a random integer token. So later on for fuzzing, we'll be replacing that. So JavaScript, what we have seen so far is CSS grammar collection, but we need to also collect JavaScript grammars as well. So it is compared to difficult than CSS grammar collection, and the collected web pages has to be some prior beautification also required of those collected web pages. So unlike CSS, full automation is quite difficult. So some manual intervention is required. So how do we do that? We have collected JavaScript grammar for different sources. So elements and their attributes values can be collected from W3 schools, and W3 schools also gives you some JS DOM event information. So for example, onload, on click. This event list of events can be found from these pages. So now I am going to show you a quick grammar collection demo. How does it work? This is a simple parser. And this is a sample template that we have collected from the internet. So we are actually interested in these CSS attribute values. So now what we are going to do, we are going to pass this raw template into the pattern recognition script that we have written. So it accepts few parameters, for example, what you want to collect and what will be the input template and output format, output file. So we have an output text file. And what you can see here, after the processing of those CSS attribute, what we have something like this. So margin is the CSS attribute, and it has been replaced by fuzzend. So when we fed this information to our fuzzer, it is going to replace those fuzzend into with a random integer for fuzzing. So this is how CSS grammar processing and collection works. So now we already have collected some of the grammars, and now what we are going to do, we are going to generate some position independent code chunk from the collected grammar. So why position independent code? So our fuzzer should be able to inject those code into any places in those template that we have developed, right? So that is why it is very important the code chunk that we develop, code chunk that we generate is position independent, and it should also be context independent. So as you can see here on the left side, the sample JavaScript code chunk, it is actually surrounded by try-catch statement, each statement. So the reason is because maybe in any position independent code chunk we have total 100 JavaScript statement, and maybe there are some error in the second or third statement. So it should not break the entire page. So that is why if it is surrounded by try-catch block, it is still going to execute all the code that are in the that are present in the fuzzing code chunk. And the right side, what you see here is the sample position independent CSS code chunk. It is quite easy compared to JavaScript. We simply append attribute and their possible values from the grammar, the collected grammar. So this is a sample of a position-independent CSS code chunk. So now we have the fuzzer-friendly template, and we have position-independent JavaScript code chunk, and we have position-independent CSS code chunk. So now in this step, what we inject those code chunks into the fuzzer-friendly template. So we now finally have the test case for our fuzzing. Now, how do we execute those test cases? So the first target we are going to be talking about is the Edge browser. So if you launch Edge browser in Windows 10, what you get to see, it launches a lot of processes. So if you are targeting HTML, CSS, and JavaScript render engine, so we are only concerned about Microsoft Edge cp.exe. So these processes are actually low integrity processes that you can see here. And for dynamic fuzzing, the main problem is you cannot inject DLL into those processes. You cannot inject unsigned DLL into those processes. So we have to come up with a static browser fuzzer, which is actually dependent on debugger instead of injecting DLL into it. So you can attach debugger to those these low integrity processes, but DLL injection is not possible. So there are actually no fuzzing framework for Edge browser was available. So we had to write our own browser fuzzing framework. So we have written a Edge browser fuzzing framework which will soon make open source. So this fuzzer is basically static in nature, and you have to write your own static test case generator for this fuzzer, and you are good to go. And since this is a framework, it will actually takes care of hangs, error handling, and crash management. So probably very soon we'll be releasing that fuzzing framework in my GitHub page. So now I'm going to show you the demo of the fuzzing framework that I have developed. So here I'm just browsing the template. Now I'm going to run the fuzzer. So we are actually using the same template, and since we are injecting code inside that, so you will have some idea which template we are using. But since it is actually modifying that page, this animation is broken. So it has some error. This fuzzing framework actually takes care of all this error. If there is any error in those during fuzzing, it will actually automatically close the browser and relaunch it. So the next target is Outlook email render engine. So Microsoft Office also comes with a very basic HTML and CSS rendering engine. So this HTML CSS render engine actually shared among all the Office application. So we utilize this render engine on a daily basis when we open any email in Outlook. So if we're able to find problems in Outlook, actually it will eventually affect the entire Office. So hence, along with Microsoft Edge, we also performed some fuzzing on this Microsoft Outlook email render engine. So the only different thing we have to do while fuzzing Microsoft Outlook is we need to collect different templates, and we can pass the same template into the template processing engine that we have written earlier. So here, what we need, instead of HTML pages, we need to collect sample EML files. So EML files are basically email files are basically email files, and it will usually start with some headers and followed by some JavaScript and not JavaScript, CSS and HTML codes. So as you can see here, I have highlighted some of the CSS code, and it also supports some of the HTML element. So to be able to perform some fuzzing on this Outlook email render engine, what we can do, we can use a open source OpenXML fuzzing framework that I have open sourced last year. So it is also this framework also takes care of the crash management, and crashes. So what we can do here is we need to write our own test case generator for this fuzzer, and that test case generator has to be static. So we can configure the test case generator along with the OpenXMoller, and we are good to go actually. And the framework actually takes care of crash management, hangs, and different things. So we need to feed you need to feed basically few things into OpenXMoller. That is the binary name we are targeting, and the command line argument, and the test case we want to feed to that fuzzer. So once we have this information, we can easily execute fuzzing using OpenXMoller. So the OpenXMoller fuzzer is available in my GitHub page. So we have performed fuzzing using around 200 systems. That is not actually the case actually. So we have used used 2 CPUs, and that was running 2 or 3 VMs in each. So we have performed fuzzing in that. So we found around 300 and 350 crashes after we performed some fuzzing on Microsoft Edge browser and Outlook, and some of the crashes were duplicate. So we have reported some of them to Microsoft, and Microsoft fixed couple of them. And so after we reported these vulnerabilities to Microsoft, Microsoft patched some of those bugs, and actually it eventually took us to the number 32 in Microsoft MSRC Top 100 list. This list actually Microsoft publish every year at Black Hat events. So based on the bugs that you report to Microsoft. So what is next? So what we want to do, we want to make the test case generator more generic in near future, so that not only browser or email render engine, you can fuzz any other application which uses HTML or CSS. So that is our next plan. And we also extend this project by adding capability to inject fuzzing code in real and more complex web pages. Because right now what we are doing, we are actually injecting codes into standalone pages. So we have a plan to do that as well. And also we'll be open sourcing that Edge browser fuzzing framework, and some of the toolkits that we have developed will also be open sourced very soon. So these are some of the references and the paper that we definitely recommend you to read. So this is Domato is a very interesting project that Google has recently open sourced. So it is a very good and effective fuzzer. So this brings us to the end of our presentation. I'd like to thank you for your valuable time and attention. So if you have any question, I am open to question now, and in case if you want to send question later on, you can send to my email address or Twitter. So thank you very much.
Thank you. Yeah. Thank you. Questions? Vous avez le droit de les poser en français aussi si vous voulez que je traduise. Je finirai par shooter quelqu'un. Hein. J'essaye depuis tout à l'heure.
My first question is, well, it's not really, okay, it's working. Is with regards to this research, is it paid research by your employer, or is it your own research?
It is my personal research, yeah.
It's okay, entirely personal, okay.
Actually, I don't get paid for finding vulnerabilities in different product by McAfee. Okay. So it is my personal research, yeah.
Okay, thank you. Okay, that's interesting. And how long did it take you to how many months, how much work?
So I have started writing this code around 2017 November, if I remember correctly, and I have reported bugs till April or April of 2018. And Microsoft actually publishes this list in July during Black Hat. So some of the bugs got patched after Microsoft published this list. So those CVs are not considered when they have prepared design. So it took around 2 to 3 months, you can say, and the fuzzing was going on. So yeah, it's kind of that. So did I adequately answer your question?
Yes.
Yeah,
Yes.
thank you.
I have one last question.
Yep.
You showed a demo with the fuzzing, and you always had a single edge instance.
The demo that I have shown, it will have a single edge instance.
But how do you know it's not a previous test case that's corrupting memory? How do you know a crash is caused by one test case and not by
So
succession of
one major
multiple?
problem that you face in edge while fuzzing edge, the edge, there will be many Microsoft HCP processes. So the framework actually takes care of that really well. That is soon going to be open source. So the main logic is we actually attach debugger to the every instance of Microsoft HCP.exe. So no matter which process crashes, we grab that test case and save it. So we add some delay as well between that, so that the correct test case, the test case that we grab is the correct one, which causes the crash.
Okay, but my question was, how do you know if there's no memory corruption? For example, one test case causes memory corruption, but no crash, and then you have a crash later on. How do you know?
What one option is when we are actually perform fuzzing, the page heap was enabled. So so in normal cases the browser may not crash, but if page heap is enabled, we can try to detect the access of guard pages, right? So it will give you more crashes. So if the page heap is disabled, you will see the browser won't crash. But if page heap is enabled and you are looking for guard page accesses in your debugger, if you have configured debugging with guard page access, then you will be able to grab some crashes for that as well.
Thank you.
Yeah, no worries.
Yes, one question. Do you track code coverage in your fuzzing?
No, actually, the work that I have presented here, code coverage was not in plan. But in future, I am planning to track code coverage as well, so that we'll have for mainly template collection. So that we'll be able to track which template is covering more code paths, and we'll try to increase usage of those template more in our fuzzing, so that fuzzing can be more effective.
Okay, thank you.
No worries. Any more question?
Ok, thank you very much.
Thank you.
Thank you. Ok, juste pour rappeler, on va avoir là une pause d'une demi-heure. Après, on va reprendre avec Renaud Lifshitz sur la manière d'utiliser les algorithmes quantiques pour contrer les primitifs cryptographiques. Ça sonne très pompeux, mais c'est vachement intéressant. Conference will be couple of times.
I touched it once.
Is they say something?
No.
Because when
I should have taken that microphone actually. I'm not very comfortable with this thing.
Oh yeah. It's too bad because it was possible, but
Okay.
really.
I was a bit uncomfortable with this thing.
Okay.
No worries. Yeah.